Hi stats class, it's Miss O'Neill. This week you're going to be focusing in on still trying to create equations of lines that are parallel or perpendicular to the equations that are provided. Because you're looking at a question that can ask it for it to be parallel or for it to be perpendicular, it's important to know the difference between the two types of lines. So first things first, when you're going to look at a picture of parallel lines, it kind of says it in the name if you think of the two L's. The idea is that no matter what direction that we go in, the lines never intersect, they never touch, they stay separate. Perpendicular lines are two lines that intersect, they cross at a 90-degree angle. And it doesn't have to necessarily be perfectly in the center, okay? It has to be somewhere in the line they touch and they create a 90-degree angle. So what does that mean in terms of equations? From 2 weeks ago, we introduced the idea that parallel lines have equal, meaning the same exact slopes. So whatever the slope of the line this equation has, this equation will also have the same exact slope. What changes is their y-intercepts. And remember, your slopes are those m values within an equation. They're movements. Your perpendicular lines are lines that have negative reciprocal slopes, which means your m's are going to have values that are flipped and reversed. Okay, so let's look at some couple examples that you might run into. First example that we see for our equations, you could take a look at them, and if I asked you to decide if this is parallel or if this is perpendicular, the thing you would look for is their m's, the values next to x. Here is my m, here's my m. Because they are the same, we are going to say these are parallel. If we're looking over here, our m values are the values next to x. This one is a -4. This one is a 1/4. So let's take a moment and think about it. First thing I need to see is that -4 has been flipped. 4 was on the top, it's now on the bottom. And then we put that imaginary 1 right underneath on the top value. So this could also have been rewritten as that. So when we reverse it, flip it. Reversing it means that the negative has changed into a positive, which this has. So we would call these perpendicular. These ones are a little harder to see just because of the fact that you have to make sure that you have gotten both of these accomplished. Sometimes I can trick you by saying that your m is a -4 and the other m is -1/4. And what people would say is obviously this is going to be perpendicular, they flipped. But if they didn't reverse it, meaning a negative didn't change to a positive or a positive didn't jump to a negative, then it is not 100% a negative reciprocal. It has not done the 2 steps it's required to do. So be careful on that, all right? Our second example, again, you're going to look for the value next to x, which I unfortunately wasn't paying attention, so this first equation didn't make much sense, but don't worry, we got it. If we're looking for our x value, the thing in front represents your m. Looking at our second equation, look for the x. The thing in front, including its sign, represents its m. Both of them are negative, both have 5, 6. These are also parallel. Okay. Jumping to our other side, look for the x term. We have 2/3. Our other x is -3/2. First thing I need to see, did these switch around? Yes, they have. Is it changing, reversing its sign? Positive to a negative? Check. These are perpendicular. In order for you to be able to complete this week's assignments, you must remember the 2 main features of parallel lines and perpendicular lines. Parallel lines always have the equal same slopes. Perpendicular will have negative reciprocal slopes. Flip it and reverse it.